Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Hello my dear students, hope you are all doing well and enjoying your learning with Pen and Paper Chemistry. In today's lesson, we do part 9 of the topic carbon and its compounds, and the only requirement that you have to do is pen and notebook in your hand so that you can take down notes for offline reference. So let's get going. Continuing with our IUPAC system of nomenclature. So we've already done the word root, we've done the primary suffix. In today's lesson, we will be talking about secondary suffix. What is the secondary suffix? As you can see, it is the surname in this compound, in this name, sorry. So if I have written Dr. Miss Anita Kumari Saxena, so Saxena is the family name. In other words, secondary suffix is going to tell me the family to which a particular class of organic compound belongs. Just a quick recall, there are limited functional groups that we are going to do in today's lesson because we are focusing mostly on the GCSE or the grade 10 or the IGCSE levels, not the A levels or class 12 levels. So we will focus or limit ourselves to 4 of these: the alcohols, aldehydes, ketones, carboxylic acids. A quick recall, what is an alcohol? When you replace the hydrogen atom in the alkane by an OH group, what you get is called as an alcohol. So in other words, my compound now becomes CH3OH. Or if you want, I will write it in another color so that you are able to view it. Similarly, you replace the hydrogen atom by the CHO group. Then what will it be? Yes, it's called as an aldehyde, CH3CHO. Now this becomes what we call as an aldehyde. So this compound is an aldehyde. The previous one is an alcohol. So please keep making a note of this. This is a quick revision of what we have done in the previous videos where we spoke about functional groups in detail. Similarly, if you replace the hydrogen atom by the COR group, or to make it simple, I will keep it as COCH3 group. Now this becomes what we call as a ketone. Now in the previous video, I have introduced to you the term alkyl, and I did mention that we do represent the alkyl by R. What is this R? Many a times, in order to make things simple or to make it more generic, so for example, if I have CH3OH or if I have C2H5OH, instead of writing the formula of each and every one of this, you see the CH3 is an alkyl group. You see the C2H5 is an alkyl group. In general, we will represent alcohols as ROH. R is the simple or generic alphabet used for alkyls. So continuing from there, this COCH3 makes it a ketone. Similarly, if I replace it by the COOH group, COOH, do you recall what is it? Yes, it's called as the carboxylic acid, and we have done all of these in great detail. In case you haven't seen this slide, you can make a note of this. So we have listed the functional groups, the class of organic compounds, the structure of the functional group, what is free valency and how many free valencies are there. Right? So secondary suffix will be the set of words that we are going to use in order to depict the presence of any of these groups. So alcohol, aldehyde, ketone, carboxylic acids. There are more as well, but as I mentioned, we are limiting ourselves to the present set of 4 functional groups. So what will be the secondary suffix used for an alcohol? Now the clue lies in the name, alcohol, OH. That means as soon as you see the functional group OH in the compound, it's an alcohol, and the suffix that we are going to use would be an ol, OL. That is why I am underlining the clue over here. Similarly, for aldehyde, as soon as you see the CHO group, that means it's an aldehyde, al, AL. Sorry, that's a glitch in my app and it keeps giving me that line across the screen. Then ketone, yes, got it, one. So, O-N-E. We will say it as own because it becomes part of a name. It's not one, it's own. Similarly, carboxylic acid. Now, carboxylic acid, we are going to use the acid over here and we will have oic, space and then acid. Right? If you recall, I had mentioned to you that we usually write the IUPAC name as one word without any space, but here in the case of acids, carboxylic acids, there's a gap over here, oic and then acid. Now let's practice writing each of these. But before that, please make sure that you memorize this, the word root and the primary suffix. We start with the first set of compounds. Now you recall CH4. Now do you recall the word root that we use when we have one carbon atom? Yes, it's called meth, M-E-T, right? T-H. So we will write the first part of our name, that is meth. Now is it saturated, unsaturated? Look at this. It's got only one carbon atom. That means my chain for this particular compound would be simply like this. Saturated, unsaturated? Yes, it's saturated. So what will be the word root? Ane. Now come to the functional group, OH. Now what is the functional group? OH. What category of organic compounds? Alcohols. What's the suffix? All. So we are going to write all over here. Now, you see over here, I'm getting two vowels together, A and E and then OL. So E and O next to each other. So what we do is we get rid of the vowel at the end of the primary suffix. Basically, what we are going to do is we are going to strike off the E from here. With the result, I get the name of this compound as methanol. So you see, a word which is as simple as methanol is actually can be broken down into three parts. And this logic of breaking down a bigger name into smaller parts comes in very, very handy when you have bigger molecules to handle. So if I give you a compound something like this, how are you going to name it as? So it comes in very handy. When you have small molecules, things are easy. But if you go by logic, you can name any compound very, very easily with confidence. Try naming the next one now. CH3CH2OH. Now, if you want, you can expand it and write it like this, CH3CH2. So H, 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 H and then OH. Try naming this compound. You have to, first of all, number the carbon chain. Now, what rule are you going to apply? Do you recall what we did when we started naming the organic compounds? What did we say? The lower, the better. Right? So, if I have to give the position of the functional group, remember the term locant? I can start from here and then go on to here. Or I can give this as position number 1 and this as position number 2. Yes? there are 2 carbon atoms. So I can either have the OH at position number 1, in which case, how am I going to name it? Help me out. Word root. H. Saturated, unsaturated. Yes, it's saturated. So, ane. Now, look at the numbering. Should I call it as 1? So, for OH, okay, let's write down the ol as well. OL means it's an alcohol because of the presence of the OH group over here. Now, either I can say that the OH group is at position number 1 or it can be at position number 2. Yes, which one is preferable according to IUPAC? Yes, wherein the carbon to which my functional group is getting attached is getting the lower number out of the 2. So that lower number is 1. So in other words, this becomes ethane 1 all. So again, because this is a vowel, this is a vowel, A, E, I, O, U, Y, any of these, if, yes, I know Y is not a vowel, but we do consider it while naming organic compounds. So if my previous word is ending with A, E, I, O, U or Y, it is done away with and we write the name of the compound as ethane 1 all or simply ethanol, because if you recall, I told you we don't write 1x in algebra, we simply write it as x. Position number 1 is generally not depicted by the number 1. It's simply indicated as ethanol. Right? Now, a very, very common mistake that I have seen made by beginners, that means those who are still trying to understand organic chemistry. What we go on to do is, we end up numbering this oxygen as well, 1, 2 and 3, and we will say this is 1. No, that is wrong. We always number the carbon chain. Remember, organic chemistry is all about carbon. This is going to be our priority. So always number only the carbon chain. Let us go on to the next compound. Now try naming it yourself first. CH3, CH2OH. Go ahead. You can either expand it or name it just like this. Step 1. Number the carbon chain. While numbering, you have to remember that the lowest number should be given to the carbon to which the functional group is attached. So, we start numbering from left to right or right to left? Yes, correct. So, we will start numbering it from right to left. 1, 2 and 3. So, how many carbon atoms in the word root? Look at the number of carbon atoms. 3. Don't count the oxygen. That's a heteroatom. It's not a carbon atom. So, how many carbon atoms? 3. What's the word root? Prop. Saturated, unsaturated. Have I shown any double or triple bonds over here? No, that means it is saturated. So what's the word root? In functional group. Now define the functional group. All. So let's join the 3 of them again and we will have prop in all. So this will be propan 1 all. Why did I write 1 all? I didn't write 1 all over here. Ethane 1 all. Did I write? No. But I'm specifically writing propan 1 all. Yes, I will. Why? Let's see the next structure. Yes. My question is the answer. Go ahead, name this compound yourself. Remember again, you have to take the longest continuous chain of carbon atoms to be numbered. So, I will not take only these 2. No. I have to take the longest continuous chain. See, they are all in continuity, one after the other. And try to give the lowest number possible. I'm not saying that every time this carbon has to get position number 1. Please don't do 1, 2, 3. That will be wrong because this is not in continuity. Also, so now also even if you do 1 and 2, that also would be wrong because I've seen many a times the students will take this as an alkyl group and name it as an ethanol. That also will be wrong because I have a continuous chain of carbon atoms here. I have to number it in such a way that my functional group gets the lowest number possible. So the lowest number possible here is 1, 2, 3. Or if I start numbering from the right hand side, 1, 2 and 3. Oh, look at that. Whether I number it from left or right, my OH group, the carbon to which the OH group is getting attached, is getting position number 2. In other words, it is equally distributed on both sides. Does not make a difference which side I number from. So numbering done. Now tell me, what will be the word root? How many carbon atoms are there? Carbon atoms, not the total number of atoms. Yes, the carbon atoms. So the word root over here will be prop. Saturated, unsaturated. Look, are there any double or triple bonds over here? No. So it is saturated. What is the primary suffix? Ane? Yes, it's ane. Now look at the functional group. What's the functional group over here? OH. So what does OH stand for? All. Okay. And what's the position of that all now? Yes, it is at position number 2. So 2 all. When we put them together, again remember, there is O, there is E. So I will do away with the E and write this name as one word as propan 2 all. You see why I wrote 1 all and 2 all over here? Because there are 2 possible structures for propanol. One is propan 1 all, the other is propan 2 all. And what is the name given to such type of compounds? They have the same number of carbon atoms, they have the same functional group, they have the same number of hydrogen atoms. Yes, they are called isomers. Iso is same, mer is molecules. Compounds having the same molecular formula but different arrangement of atoms in them are known as isomers. So I'm now going to give you another nomenclature to do. CH3, CHOH. Go ahead, name this compound now. Try it yourself. Did you get it? Okay, let's start again. Naming this organic compound. 1, 2, 3, 4, 5. There are 5 carbon atoms in one continuous chain. Remember, when there is no bond shown between the carbon atoms, it means a single bond only. So I'm going to number it. Now again, tell me, which side should I number it from? Left to right or right to left? Let's see. 1, 2. 3, 4, 5. That means my OH group is getting position number 2. Now let me start numbering it from right hand side. 1, 2, 3, 4, 5. What position number does my OH group get? It gets position number 4. Which one is better? IUPAC says lower the better. Yes. Smaller the better. Smaller the number, the better it is for us. So we number it as 1, 2, 3, 4, 5. 5 means what will be the word root? Very good. Pent. Saturated, unsaturated. saturated. So ane, ene, yes, ane. And then functional group, all. What's the position of that functional group? 2. What do we eliminate? What do we remove? The E. Last step, what do? We just join the 3 parts and we have the compound pentane 2-ol. Okay, can you try and draw the structure of pentane 3-ol? Try it. Isn't it getting interesting? Are you liking it? Do let me know in the comment section. Your happy, smiley faces and your beautiful comments actually make my day. Honestly, that gives me the energy to go on. So don't forget to comment and share your positivity. Pentane. Yes, pent. Pent means I have to draw 5 carbon atoms in a chain. That I've got now. 1, 2, 3, 4, 5. Right? Ane. Ane means there is no double or triple bond in this chain. 3-ol, that means at the 3rd carbon atom. Now here I have only got a chain. I'm not naming, I'm drawing. So I can start counting from the left hand side itself. 1, 2, 3, 4 and 5. So at the 3rd carbon atom, what functional group do I put? Yes, I will put all. So OH over here. What's my last step? Is it complete? No, I have to put the hydrogen atoms. How do I put the hydrogen atom? Remember, the valency of carbon is 4. Only one valency is satisfied over here. So I will put hydrogen, hydrogen, hydrogen. Let me remove the numbers in red so that you don't get confused. You don't think that it is written as. Now, look at this carbon. It's already forming 2 bonds. So that means how many hydrogens to be attached? 1 and 2. How many hydrogens will there be any hydrogen on this carbon? Yes. How many? 1. How? 1, 2, 3 bonds already formed. How many more bonds can it form? Only 1 more. Similarly, here and 1, 2, 3. I can also write this compound as CH3, CH2. See, where does my CH3 come from? Here. CH2, CH, CH. Now this OH, I can put it in brackets indicating that it is connected to the 3rd carbon atom. And then again CH2, CH3. Can you tell me one more isomer of pentane 2-ol? So we've got pentane 2-ol and pentane 3-ol as isomers. What one more? Yes, you got it right. Pentanol. Now your homework is to give me the structure of pentanol. So you've learned another thing today, and that is to draw the structural formula. So one is you've been given the structure and you write the name. The reverse is called writing the structural formula, which we will practice even more as we go further to the next set of functional groups. So stay tuned as we deal with aldehydes, ketones and carboxylic acids as well. Please don't forget to recommend the channel to your friends, classmates, juniors, seniors, whosoever you feel may benefit from learning chemistry in an easy, fun way. Have a lovely day. The only mission of this channel is to make learning chemistry easy and fun for all you students, with the help of the periodic table, the flow charts, the graphs, diagrams, dealing with numericals, how to deal with numericals. And this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel. There is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.